Welcome to the Passive House Podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House Podcast. Welcome back to the Passive House Podcast. I'm Matthew Cutler, coming to you from Auckland in New Zealand, and I'm joined this week by Mary James. How are you doing, Mary?
Very well, thank you.
And also Ilka. Good to have you back on the podcast. I think it's been a couple of weeks, hasn't it, Ilka?
Yeah, thanks. I was actually at the NASI conference, which was a great experience. Yeah.
Nice. Well, hopefully get to hear a bit more about that. We've got a little bit of a different conversation this week brought to us by Ilka, and so we'll get into that. But before we do, I just want to do a quick shout out to supporters of the Passive House Accelerator and the podcast. So firstly, our stakeholder partner, big thanks to NYSERDA, and our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwall and Zola Windows. And thanks also to our champion sponsors, Buizo, Cascadia Windows and Doors, European Architectural Supply, Facro, Icon Windows and Doors, Intelligent Membranes, LG and Source 2050. And I'd like to do a special thanks to Cascadia for being the main sponsor for this week. Really appreciate their support. All right, Ilka, I heard a lot of voices on this conversation that you recorded, a lot of great work from you, but also the great work that is being talked about and going on. Can you just paint the scene for us? Where were you and who were you talking to?
Yeah, so we are going to hear a lot of young voices, which I'm very, very excited about. And what this was is actually the Reconstruct. It's a workshop, and it's mainly revolves around deep energy retrofits. And Michael Gemtrut is spearheading this effort, and it's basically a workshop where several other universities actually and their research labs take place, and it's all about prefab. So Steve and I were invited to present what we've been working on our end within the industry, and it was really, really great to bring that to the academic world and hear about what they're doing, because I, to be honest, had no idea. And it's just so nice to hear that they're all different different fields working on the same goals here. And I really, really wanted to share what these universities are working on, and I was very excited to hear all the young voices, as I said. And then the other thing, I actually intended to only interview Cheryl Boyle because she's amazing and what she does, and we'll hear a lot more about it. But she said she would only want to be interviewed with her students and associates, research associates. So it became a larger group, and then we decided to just all stay after the workshop for a little bit longer and hear about what everyone does. So yeah, lots of voices, but very, very positive and exciting things are happening.
Yeah, there's some really cool things in there. And just before we push play and listen in to some of the work they're doing, it's a little bit of terminology. One of the things that was mentioned was SIM, which was defined, but can you just give us a quick summary or definition of what SIM is?
Sure. So that is actually something that Steve and I have been developing over the last so many years within Holzraum system, and we call it the single integrated manufacturing model, because what happens when you start working with a manufacturer is the model that they use to pre-manufacture all the wall panels, in our case, the model has to be a parts-based model, right? So because everything that needs to be fabricated has to be built in the computer first. And what we realized is that once you have that, there's so much potential to use that in so many more ways, because all of a sudden, whatever's in the computer actually gets built exactly like that. So then you have these opportunities of clash detection and looking at this virtual twin, this digital twin beforehand, so you can start using it as a communication tool, but you can also integrate load path and MEP and even concrete work. So it's a way more holistic approach to it. And it really comes down to communication and collaboration. And yeah, that's what we've been using. And that's what we presented to them as a process.
Well, and they're obviously embracing that. So let's listen to your introduction, recorded live, and then we'll hear all those great young voices.
So welcome to the Passive House Accelerator podcast, and this time actually from McGill University in Montreal. So this is the end of a 2-day workshop, the Reconstruct Workshop, which is focusing on retrofits. And Steve and I were just honored that we were invited to participate. But what I would like to do now at the end of this workshop is share the amazing work that these universities are doing, that you're all doing. And what's amazing is that it happens across several different universities, several different research labs. And for me, hearing about the work that you are doing is just so inspiring and hopeful, because what you're able to do is diving into the research, sharing that, and training the young people. They are going to be the ones going out into businesses, into the field, and they will be the ones changing the industry at the end. So, Michael, would you like to start and tell us about Reconstruct?
All right, I'm Michael Jemchud, professor of architecture at McGill University, and the lead on a major research project called Reconstruct, which is focused on developing a deep energy retrofit program for Quebec and Canada. And we have a great group of students with us that will speak shortly. And we're very happy to have Ilka and Steve here to show us the SIM platform and the Catch platform that relates to the manufacturing processes that we're trying to teach students and utilize in our own research and our own efforts to develop pilot projects for deep energy retrofit here in Quebec. The students here have different research projects or research goals. We also have colleagues from Carleton University who have their research groups here. And it's been a really great 2 days. And thank you very much for sharing all of your wisdom and knowledge with us.
Well, thank you for having us. So you mentioned SIM. We should probably explain that. Steve, can you very briefly explain what SIM is and how it relates to Reconstruct?
I'm Steve Hessler from Holstrom System. Ilka and I are super pleased to have been invited into this wonderful workshop. One of our goals was to explain a workflow that we've sort of evolved with the goals of bridging perspectives and workflows between architects, factories, and manufacturers, and also developers. The workflow that we use through a DFMA process is what we call sort of an expanded workflow. The single integrated manufacturing model is the model output, but it's also the process where we use data attached models and a very collaborative workflow to engage and bring in ownership and input into our model, attach it into our model and the workflow, and stay connected with project teams iteratively, but through a linear fashion to an end goal of, in our case, typically producing a building of sometimes on-site and typically multiple off-site construction components like panels and roof panels and trusses and load path. And now after this wonderful 2-day workshop, we feel more committed than ever that there's a synergy here to develop a curriculum around some of our ideas and some of their amazing work, and to create a tool set that could become useful beyond all of us.
Thank you, Steve. So Michael, why do you think it is so important to integrate all these new technologies into the university, into the research labs? Students learn about it, and why is it important for the industry that you do that?
Right, yeah. I mean, what we do in the lab is very applied, and the goal is to work with industry and communities actually to do a lot of the work we want to do. Since we're focused on overcladding solutions for retrofit, prefabrication is essential, so that's a major reason why we're interested in the SIM platform. And then the kind of work that we do, because it is applied, also involves like trying to make decisions, and that is a design decision-making process, but it's also financial. It's around the environmental concerns, around the performance of the buildings, around community resilience. So there's a lot of moving parts here, and that's why we have a large interdisciplinary team, I guess, on this research project with the Carleton colleagues and University of Quebec at Montreal and University of Toronto. I should mention everyone. Yeah.
Can you talk a little bit more about your pilot projects?
So we've been, like I said before, we've been working on developing some designs for pilot projects, and then working with the clients of those projects. We're looking to find projects that fit into what we call a pilot the pipeline strategy. So choosing projects that we know if we develop one overcladding solution for it, that we can somehow replicate it, that it's scalable. So, we're focused on a community center in a municipality here in Montreal that is a prefab steel building, and there's just thousands of those buildings across Quebec and Canada that could and should be fitted, especially if they're community centers and hockey rinks, things like that, but grocery stores as well, and other similar types of buildings. The other one is multi-unit residential buildings, so we've been developing some solutions for that. And a big part of that is how you prefab those envelopes. So that we've been looking at details around that and educating the students on how that works structurally, as well as from an envelope thermal perspective. So yeah, I mean, it's a design research project, and it's meant to be very applied. So of course the tools that are all around that, design tools, are really important to us. So, and understanding the prefabrication process as architects and engineers is also essential. So the kind of platforms and tools that we've been discussing in the last 2 days are just essential to that effort. So one of our research associates, Gabby Goldman's going to speak to some of the challenges that we actually encounter with working with these municipalities and groups in developing these pilot projects.
Yeah, so my role as a research assistant and recent graduate in architecture in working with Michael and the team is looking mainly into social housing and how the system, whether it's panelized, prefabricated envelope, or other systems, can be applied at scale to social housing in Quebec. So we have a really big amount of social housing that's owned by the government, that's all repeated typologies, really ready for a prefabricated high-performance envelope solution. And so we're looking at how to make relations with them and help them understand the kind of benefits, whether that's resilience, improved health, the kind of benefits that come to residents, as well as the ones that come to the building owner, improving the longevity of the building, investing the total cost of operations, so looking at costing over time, energy savings, carbon savings, and then building those relationships to develop case studies of their buildings, as Michael mentioned. So we look at the technical aspects, but my role and others on the team is really trying to build those relationships so that we can access their data, we can work with that data, build tools around it, and sort of help them prioritize a pipeline of buildings that they might want to go and retrofit. So helping them get ready for that next step is what I kind of do on the team. And David works a lot in tools, another area on our team who can talk more about that.
Yeah, I'm David Sorokin. I'm a research associate. So when I first joined Reconstruct, I was really trying to figure out what's the major blockades for retrofits in Quebec. And then I kind of highlighted two. So the first being we're in Quebec where we have hydroelectricity, so very cheap electricity and pretty low carbon electricity. So the value case for retrofitting is a little bit more difficult. So we expanded kind of our selection criteria for buildings to what we call non-energy benefits. So things like health and well-being, the technical capabilities of doing that retrofit. And then the other issue we found in talking to some of our partners and retrofit accelerators was that they were engaging in these what we call feed studies, front-end engineering design studies, that are very onerous, kind of take months and take a lot of capital to produce. And so there was this need to create a system or a workflow to systematically assess buildings very quickly and to be able to introduce these non-energy benefits as part of the value case as well. So I created a tool based in multi-criteria decision analysis, which tries to quickly encapsulate all of these different benefits and then find optimal buildings out of a stock.
I'm Antoine Kilak. I'm a student at McGill. I'm doing my first year of master's right now. And I've been working with Reconstruct for the past year almost. And so I can maybe speak to my experience with Reconstruct more broadly. I worked last summer on a pilot project that we did for a MERB here in Montreal. And so I've been implicated with the technical, the architecture team. And so I've been working on like these solutions on how to integrate or work on a panelized retrofit for this type of building. And so I've been trying to identify those, challenges that would come with like integrating a retrofit for this building. And so, for example, one of those issues would be like working with the balconies that are very important for social housing, obviously. And so we've been developing those strategies, solutions for this type of issue. And so I think that's an example of what I've been doing.
My name is Rochi Wang. I'm on the team of Reconstruct, and I'm a research associate here. I've joined the team since 2 years ago. When I first joined the team, I think, like my colleagues have said, there were a lot of barriers because we're trying to do something very innovative, and we're trying to launch this mass deployment of deep energy retrofits through a very quickly, rapid, and systematic way. And that is why we started looking at this digital tool suite that David has spoken about. And through that decision-making framework, we also started looking at different tools such as a cost calculator and life cycle assessment calculator. And our approach to these tools is really more of a quick and dirty approach because we're looking at stock of buildings and not just individual piecemeal renovations. We wanted to be able to shift through these stocks quickly, effectively, and efficiently. And that's why we are working on this digital tool suite and try to realize and get to concrete deliverables through our team's collective work.
Hi, my name is Peter Osborne. I'm faculty at Carleton University, technically professor of climate adaptation and building rehabilitation. I've been involved with Reconstruct since the beginning as a PhD student. Initially, my work surrounded kind of impact assessment, life cycle assessment, carbon impact assessment, and the development of biogenic solutions for panelized retrofit that were easily adoptable by industry. So one of the examples is we developed essentially an insulated panel that simply substituted, wood fiber insulation for kind of standard rock wool insulation, and did some testing with our colleagues at the Center for Advanced Building Envelope Research at Carleton. Now I've moved on and graduated from my PhD here, and I'm working as faculty at Carleton. And my research broadly, again, looks at kind of this scope and scale and kind of systems analysis of what we are kind of working on, and how to synchronize the kind of manufacturing process from its sourcing of material all the way to its application at the end of the day. So I've been part of essentially a research through McGill looking at the kind of existing infrastructures in the region for panelized retrofit solutions, for modular retrofit solutions and such, and essentially began to kind of realize that the impact needs to be traced all the way back to its origin in forests, especially when we're looking at biogenic materials. So now I've begun to kind of expand that research into essentially carbon assessment and ecological impact assessment, as well as ecosystem services assessment, that assesses and understands how these kind of large manufacturing goals that we have, this 10,000 buildings that we're trying to retrofit right now, will impact the forest and the kind of natural environments that we build with.
Amazing work. So what's really interesting about this, besides looking at the bigger picture of how manufacturing affects the forest, is also just identifying all the materials and all the different, very nuanced materials that manufacturers are using, and basically naming and cataloging them in a way that they can be compared, that there's a database that is aligned. And speaking about databases and storing information in different ways, Stephen, would you like to share what you're working on?
So I'm Stephen Fye. I'm a professor at the School of Architecture at Carleton University, and I'm the director of a research group called the Carleton Immersive Media Studio. And our role in Reconstruct ties into our work that we're leveraging work that we've done in the past in heritage recording, and using building information modeling in the context of heritage recording. And our role, initially at least, was to scan and model the examples of retrofits. That has grown somewhat. Start looking at what information is required, what information requirements are needed in this process, what information exchanges are required between builder, architect, and owner. And also looking at the potential of leveraging digital twins in this process. So again, exchange of information between a physical thing, a digital thing, in an ongoing near real-time cycle. And Christine Prochnow, who has been a PhD student in our program, part of our lab, has been leading that modeling effort.
My name's Christine Prochnow, and I'm a PhD student at Carleton University. So our initial work was around the first pilot project for Ilbizard, which was capturing the building and then modeling it. And out of that has really come questions of how much detail is enough in the model of the existing building that you're going to base all of your panel design and decision making and a lot of the initial simulation cost forecasting of this retrofit project off of. You need to understand the existing building, which often doesn't have accurate or existing documentation of what was built. And so out of that initial process of documenting that real building, there's been a lot of questions of where do you need to capture detail in the building capture. And then one of the biggest bottlenecks is transitioning from point cloud data to semantic data in a model environment that architects and engineers and other stakeholders in the project can actually manipulate that data, because point clouds are just coordinates. And you can't actually use that information within some of the more advanced tools like SIM or Catch, or like you can't really access the information that's in a point cloud. And so that's a huge bottleneck that's still currently mainly done by hand, is the most accurate way to go from point cloud to model. So Simone Filico, who's another PhD student, and I have been working on that. And then how does that translate into all of these questions of IFC and interoperability between different softwares, of what different people in the kind of puzzle of a retrofit project would be using and needing.
One of the things that I actually didn't mention with regard to our earlier work was actually looking at the impact of keeping these retrofit buildings in use, right? So one of the big efforts that we initially were challenged with was translating that point cloud model into an actual model that could be utilized for, collecting a bill of materials to do a life cycle assessment on. So that was a really interesting process that really revealed the kind of the limitations currently of, early design tools and early design making tools have right now dealing with retrofit applications, because oftentimes like what's inside that wall is not necessarily known. This is also one of the reasons why we're trying to use standard buildings that have replicability across lots of places, so we can hopefully use this kind of initial information that we developed during those initial studies to help guide municipalities, stakeholders, et cetera, in their decision making process. So I think that kind of translation process will be really benefited from this research, and I'm really hoping that people will begin to realize how important it is to build with the materials and the buildings that we already have.
I'm Simone Fallica. I've been part of the SIMS Reconstruct branch of the project. Actually, as Christine just summarized, we have been focusing on the documentation side of it. Me specifically, I've been researching about the idea of using the information contained in these building information models as a real language. So how should we find a common ground in terms of communicating that information to multiple platforms, multiple kinds of experts in different fields, which is where the importance of the IFC standard jumps into the project.
Awesome, thank you. So yeah, communication is just so important, and being on the same page and looking at the same things, basically. So for me, I always have this image in my head, and I think I showed it earlier, about this elephant, and there are like 5 or 6 people touching the elephant, blindfolded at different parts of their body, like the trunk, the ears, the feet, and everyone sees something that is actually not elephant related. The one person says, I have a snake here. The other one person says, I have a tree trunk here, or a fan. And yeah, I think that's just such a good image for what we're talking about, and that we actually have to basically take the blindfold off and see the whole elephant, and then we can see parts of it and dissect it and look at the trunk instead of seeing a snake. So yeah, I think it's really important what you're all doing. So Cheryl, I was so happy to meet you, and you're the director of Sea Salt. Can you tell us a little bit more about that and what your students do?
My name is Cheryl Boyle. I'm the director of the Carleton Sensory Architecture and Liminal Technologies, so Sea Salt Lab at Carleton University in the School of Architecture. And so I have research projects, but I'm also teaching. And in both endeavors, I'm really trying to bring digital design and fabrication at least closer together in the links of the software that they use. Instead of playing this game of telephone, and translating between one software to the next, and somehow losing sense of the qualitative side of materiality that architecture is really linked to. And so how do we kind of seamlessly, or as seamlessly as possible, link that to, new technologies, not just in the design component, but in fabrication. So DFMA is a big part of my work. Certainly prefabrication is really an important part, including a prefabrication studio. But most importantly is just my role in as a research enabler for my students and their various projects. And I think they can probably best speak to that, but it really touches on everything from robotics to materiality to ethics, and I'm just super glad to support them.
My name is Frank Kinopoulos, and I'm a recent graduate from Carleton University. I worked with Cheryl on a number of research projects, and including my own sort of interests in research. What that really entailed was looking at how supply chains have impacted our architectural ecosystem, and seeing if we can minimize the travel time between where materials are extracted from and where materials end up in our buildings and eventually in the landfill, and seeing how we can possibly, as much as we can, divert as much of that material from a landfill to other uses. That led into research project that focused on parametrically accounting for typical Canadian homes in terms of volume output for each type of material in those homes, and seeing where those materials can possibly be used again, calculating the embodied carbon, and just having a bunch of processes and seeing eventually getting into creating a tool through Grasshopper that is able to calculate these volumes very easily through a simple line input, and get embodied carbon volumetric data that can then be used in an embodied carbon calculator to see how much impact can be averted by reusing materials.
So my name's Adonis Lau. I'm a researcher at Sea Salt working with Cheryl, and my research is sort of focusing on or building upon the prefabricated retrofit panels, but looking at the fabrication side of it and how we can leverage sort of these new state-of-the-art advanced fabrication tools to see how we can sort of design or think of new ways to design these panels rather than sort of the typical stud frame wall that we're building currently with a traditional prefab. But the idea is sort of if we're already getting scans from the existing buildings for where to place the openings and things like that in the panels. But what if we also use the deformation of the existing wall, because with retrofits, all of the existing buildings over time deform, and some deform over more than others. So with these overly deformed existing surfaces, how can we leverage parametric design combined with advanced fabrication tools to develop new panelized systems or structures to sort of try new things, I would say, to see kind of what works, what doesn't, and try to bridge advanced fabrication tools with a big problem we have, a design problem we have in Canada, I would say. But then another aspect of the research is about scale and how robotic code and processes in architecture scale between small-scale fabrication and large-scale fabrication. Because one of the things we're thinking of is maybe in an architectural office, you have a small-scale collaborative industrial robot where you're testing processes of assembly and fabrication at a smaller scale in a safer environment where it's lower risk, lower material waste just due to the physical size. But then as an architectural office, you're already thinking about how the assembly can get built with these new tools, and then the conversation between the architect and the fabricator, there's less of a gap between the two because you're starting to talk the same language. You're starting to think the same way of how things can be built and how you choreograph these tools so the design intent doesn't get lost in the middle of this translation between design and fabrication.
I'm Michaela Gibson. I'm a research assistant at the Sea Salt lab. And beyond that, I was also a student in the prefab course in the Masters of Architecture program that Cheryl had talked about. So within this course, we were asked to look at a number of prefab companies and map out their supply chains. And we all shared this information amongst each other. So then when we went to go design our final studio project, we were able to make more informed decisions about the materials that we were using based on the supply chains to be able to then design our final studio buildings.
My name is Sam Lane Smith. I'm a part of Carleton with the architecture faculty as a research assistant in the Sea Salt Lab. One of the primary projects that I've been engaged with and the team that I've been working with is grappling with is the realization that incorporating prefabrication into the design workflow requires fundamentally rethinking the way we design. And initially our partners within industry who were with building experience were expecting us to come to them quite early on with floor plans and ideas on form and how this is going to operate experientially. And perhaps slightly surprised when we showed up with maps talking about the suppliers that are making and where they are in relation to the projects that these builders are imagining. And so within the scale of that, they're looking at a multi-unit residential in the 5 to 8 story range. And so then understanding that within that, you've got certain structural and thermal capacities that had to be designed into that. But if we're going to be looking at this as a prefabrication issue, then we've also got the logistics of moving from supplier to perhaps assembly plant to site and then the scheduling of that. And so with our initial look at the supplier network, we are challenging them to also rethink their value placement in terms of what types of materials are we using, how are we using them, and how are we designing them to ensure that they can be transported in order to inform that. And so shifting that paradigm that we often as architects operate within in terms of the form and the function and how that relationship is already so tightly intertwined, and adding the additional manufacturing and design for manufacture as a leading issue.
My name is Catalin Bacalo. I am a research associate as well at CSALT, and my research focuses on precast concrete panels, more specifically for foundations. And the focus was really to look at something that is adaptable to different types of buildings in size. So traditional panels, the way they're made in North America, are very wasteful. So the formwork, for instance, in many cases is made out of wood or steel if it's a more reproducible product, but most likely out of wood. And I wanted to look at it in a perspective where if I'm going to create these panels, how can they be adaptable while not being wasteful in whether it's hardware or whatever it is, or whatever it takes to create these panels. And so to create these panels, I had to redesign the way they're made. And that went back into looking at the plants, the local plants. So working with Central Precast, we visited them many times, and over the many visits, you realize there's a lot of products that, especially flat panels, that the wood itself gets thrown out after so many uses. And so I looked at it from an automation perspective, and how can these panels be recreated and be customizable in order to achieve the same product, but in a more efficient way, and while reusing the formwork over and over again. So I ended up making a kit of parts for the concrete panels with adaptable members, and a catalog of parts for a formwork system that could be assembled and disassembled through 6-axis robots, whether it's through gantry or whatever it is. but it all comes together into one big play in order to achieve that one final product. So it's not just a product, but it's also the process and working with the people that create these panels in order to adapt the way they make it. So it's really adapting an existing factory to make it possible for them to achieve these shapes. So it's easy to design, but in the end, it's about, is it easy for them to make it too? Because if you streamline that process, it's a lot easier for everybody. So it's not just, I make it as an architect, I make this panel and they're gonna figure it out. It's not quite that easy, right? You have to think about the manufacturing and the assembly of the components that make these panels. So that's what really my research is about.
Amazing. Thank you so much, everyone, for sharing all these insights. And yeah, I mean, I am just so beyond impressed with the depth of the research regarding prefabrication, and that the goal is to make it available to the industry. And also, I'm just hoping that a lot of people are listening and are taking, seeing this as a great example of a school or schools working with each other and seeing this as an opportunity to work in an interdisciplinary way, because that's going to be the work world as well. So we have to burst all these bubbles. We have to burst as many bubbles as we can and work with each other. So thanks again for having us here. And then last but not least, I would like to invite Frank to say a few final words, because Frank has been the glue of all of this. He's been herding the cats, basically. And I think he has a really great insight into this program. Frank, do you want to say a few finishing words?
So my name is Frank Zurich-Gulick. I'm the research coordinator for Reconstruct, the Reconstruct initiative that's led by Michael Gemtrude. There's also another research group that plays an important role in Reconstruct, which is based also at Carleton. It's called CABER, the Center for Advanced Building Envelope Research. It's led by Cynthia Cruikshank, who's in mechanical engineering. And there's also Milan Riva, who's at McGill, who leads the chair in housing, community, and health. And she looks at the health and well-being impacts of retrofits. So she's looking more at the social science dimension. She's in geography at McGill. So maybe that's a good segue to how an important part, how I see my role. And when I started the position, this is what I foregrounded, and Michael said, that sounds just right, was to really facilitate communication and collaboration between all these research groups, but then also with groups outside of academia. And so what appealed to me, well, there were several things that appealed to me about Reconstruct when Michael proposed this project, this role to me, was that this very interdisciplinary nature of the work. And I think when we host these workshops, it's really an opportunity to bring people in who are at different institutions and also different fields or different specializations within those fields and other sectors. So there's always people who come who are not in academia, who are interested in the work we're doing, and who are doing work that we think is interesting. And so trying to address these tricky problems and to innovate in this field requires collaboration across disciplines and across sectors. And that is based on being able to communicate and also building relationships. And I think I didn't exactly know what to expect from what you and Steve presented during this workshop, what Holtram System presented, but a huge element of that, what I heard, is that it's about developing tools and processes to facilitate collaboration and communication across different disciplines and sectors and organizations. And so that's very exciting for me, and it feels like extremely like a really good fit with what we're trying to do. So the research that we do is broken up into smaller projects, but we're constantly coming back together through different modes to share what's happening and to say, oh, I need information from you, or I need to, this team needs to talk with this team or needs to work more closely. We're trying to develop those processes as an industrial process to realize these retrofits. And then we're also constantly adjusting how we communicate and how we do the research and how we develop the content and the material.
So from your point of view, how do you see all of this feeding back into the industry, and how does everyone benefit from this relationship?
Well, I think a really important part of what we're trying to achieve that I unfortunately sometimes forget, but I was here, is that there's a huge need to build capacity. And some of how you build that capacity is we're doing this work together with students, and then these students are going out into industry. And I've given references for people who say, oh, wait, this student did this, 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 and this over the last year or 2 years. That's amazing. This is the kind of person that we need to address these challenges that are very interdisciplinary, that need a lot of autonomy and creativity and problem solving. And again, we see these pilot projects as an opportunity. It's the industry actors who will realize the pilot project. And so we've assembled a whole package of reports and recommendations and tools that we've developed so that to say, well, this is all the background work we've done. These are the concepts, the analysis we've done. Now you can build on that and benefit from that. And so the investment you need to make to develop an innovative solution for this particular building is much smaller. And then depending on how you define industry, there's a whole network of not-for-profits in Canada who are funded to accelerate deep retrofits in Canada and or to realize retrofits, deep retrofits. And so we're in regular dialogue with many of these organizations who are on the ground trying to do this work and who need tools and have questions that come up. And then we say, oh, well, this is this tool we're developing. How can we adapt it to support your work?
Yes, so thank you, Frank. That was these are really nice finishing words to the interview. And I also want to thank everyone else who spoke and shared their knowledge with us. So Matthew, what do you think?
Well, I want to thank you, Ilka, for being there, and great to be acknowledged and to have your work taken up, I think, and obviously, must be quite nice to have all those young students embrace. I guess the thing that stood out for me was just so much amazing work being done. It gives me a lot of hope for the future generation of knowing that these architects, graduates, postgrad students doing this fantastic research and really picking up on some themes that we've heard of for a little while now, things like digital twin and offsite manufacturing, prefabrication, using panelization as a way for retrofitting. And a lot of these problems have been put in not the too hard basket, but they're pretty challenging. Having to think of ways to standardize rebuilding or retrofitting of what seems to be non-standard building. But then it was interesting hearing about ways that you might potentially be able to classify types of existing buildings and find commonalities within buildings that may look very different, but may actually have some similarities in how they're put together and the general structure, and then saying, well, how can we, to what degree can we standardize an approach to make retrofitting of all those existing buildings that much more cost effective and achievable. And that, that concept, I'm really fascinated by emerging technology to be able to do things like create digital twins of existing buildings. And occasionally on my social feeds I see these pretty impressive looking videos of digital scanning techniques. I don't know how much of that's realistic or just fancy videos, but it looks pretty promising to see what's possible now, and with some of the technology that you've also been looking at.
Yeah, and I just wanted to add what's really interesting about that too is that, and Stephen and Christine are talking about it. They're part of SIMS, and they're really trying to figure out how to communicate. There's communication again, right? So doing the point cloud, all the data, these are all data points, but how do you actually turn that into a digital twin, and how do you exchange files with everyone who's working on it? It's actually quite complicated to streamline that. So yeah, there's technology on one hand, but again, what's so important is to realize nothing can get developed in a bubble, right? There needs to be crossovers. And I feel like that was a common theme throughout the work that everyone is doing.
Yeah.
And I was really happy to hear that.
Mary, what did you think?
Well, it was really exciting to hear Ilka, because I've spoken with Michael Gemtrud before, who's initiated the Reconstruct project. And, deep energy retrofits have been an interest of mine for a long time. And scaling up deep energy retrofits is a very exciting project. But what this series of interviews really brought home is the complexity. I mean, because there are the technical issues, such as you were talking about, scanning a building, and how do you identify what's the really critical information that you need from those scans, rather than just like dealing with the massive information. But then there's also the choosing the buildings, the economic feasibility of the projects. There's just so many layers that you have to deal with. And that's part of the reasons why, this is not an easy problem to tackle. Yeah, I just really appreciated that this research effort has such a practical and, to my mind, societally important goal that they're working on.
Yeah, and I think for me, it was just almost mind-blowing, the opportunities and resources that the universities have to dive into it, but it really benefits the industry, right? In so many ways, because they talk about that they want to connect and they share and they benefit from each other. But then the other thing too is that by doing that, you really prepare students or research associates, the next generation basically, for a new way of thinking, right? Because, and I think I think its name was Sam, he described it very well, that it's almost like a paradigm shift where you think about design differently. You can't just go from the architectural side. It's not just about form or function anymore. You also have to think about, once you go with prefab production, you have to think about the kind of how it gets prefabricated and work backwards from there. So it's a very different way of thinking, and I'm so glad that these students and young people are learning how to do that, because they're going to bring it into the AEC profession. And they're, at the end, I think I said it before, I truly believe that they're going to be the ones that are going to be able to change that way of thinking towards prefab adoption.
one other final comment from me was right at the top, something that I related to coming from New Zealand, where we also have a lot of so-called green energy, a lot of hydro, renewable grid. And the comment was made that sometimes it can be harder to make a financial case where in a situation like Montreal or places where they have lots of hydro and you're trying to make an environmental or even economic case for reduced power. But there's still a really good case to be made, which is about health and just a general improving well-being, but also reducing the carbon, whether it's embodied carbon upfront or the ongoing carbon. And I think that's bringing in that sort of market forces and looking at the wider societal benefits, not just the pure energy balance of how to make buildings perform better. Because that's bringing all of this potentially quite academic science into a real world application and dealing with the realities of the market forces and how you make all this sort of financially stack up. So it was encouraging to hear that sort of sense of reality in this as well. Otherwise, there's the risk of it becoming a bit of an academic bubble.
Well, and I think that was kind of clear when Michael said they're really focusing on these pilot projects too.
Yeah.
Right. So that connection is very, very important to them. And I think that's one of the reasons why they invited us in as well.
Yeah. Well, and that's great because reaching out to people like yourselves who got that real world business experience of doing this out in the marketplace.
And just as a quick comment, I mean, what % of architectural education is devoted to retrofits? Like a tiny, tiny portion, generally speaking. It's really exciting to hear about this research where retrofits are the focus, not some afterthought. So that's great.
Great stuff. Well, thank you very much for that, for making the trip. It was great that you could get there and great that you could pull out the microphone and record all of those voices in the moment. Really, really, really cool. So coming up this week on the Accelerator, it's the time of the month for a fantastic project. So project of the month will be the highlight of live this coming Wednesday, and also on Thursday there will be a Cascadia component spotlight. So check that out over at the Passive House Accelerator, and we'll be back again next week on the Passive House Podcast.